To determine the bottleneck of this process flow, let's start out by calculating the capacities at each of the stations. The capacity is equal to the number of resources, in this case one worker, divided by the activity time performed by that worker. For station A, this will be equal to 1 over the 68 seconds of activities. At station B, 1 over 60. At station C, 1 over 70. At station D, 1 over 58. Station E, 1 over 75. And at station F, 1 over 64. The bottleneck for this system is equal to the station with the lowest capacity. In this case, station E, which has a capacity of 1 over 75. So therefore, the answer to part A, the bottleneck, is at station E. For part B, to determine the capacity of the overall system, we'll take the process capacity, which is equal to the capacity at the bottleneck, 1 over 75, and multiply that times the number of seconds in an hour, 3,600. This will get us a capacity for the entire system of 48 watches per hour. For part C, what is the direct labor content? This is equal to the activity times at each of the stations. So we can sum up 68 plus 60 plus 70 plus 58 plus 75 plus 64. The sum of those activity times is then equal to 395 seconds. This is the direct labor content within the system. D asks for the utilization of the worker in station B. This is equal to his own labor content, 60 seconds, divided by the cycle time, which in this case is 75 seconds, based on the capacity of the bottleneck. That's equal to 80%. For part E, it asks us how many minutes of idle time will the worker in station C have in an hour. The worker in station C works 70 seconds on each unit. The cycle time of the machine-faced line is 75 seconds. Therefore, he'll have idle time of 5 seconds per unit. We know in a given hour that the conveyor belt processes 48 watches. So if we multiply that 5 seconds of idle time per watch times 48, we get a total of 4 minutes of idle time at station C per hour. The last part, part F, asks what time it'll be when the assembly line has processed 193 watches. To determine this, we must figure out how long it will take the first watch to complete the entire cycle, and then for every subsequent watch, it'll roll off in the 75-second cycle time. Therefore, we can compute this answer by knowing that there are 6 stations, each of which have a cycle time of 75 seconds. That'll be the overall time for the first watch, plus 75 seconds times the next 192 watches. This gets us to a total time for that of 14,850 seconds. If we compute this into hours, we then get 4 hours, 7 minutes, and 30 seconds. If we assume that they start work at 8 a.m., this gives us a time of 12 o'clock, 7 minutes, and 30 seconds when they complete the 193rd watch of the day.